Thank you for this opportunity. My name is Sudhir Jambhekar, slightly mispronounced earlier, and Peter Weingarten is on my right-hand side. We are here to actually talk about a project that we're currently doing in India, but our angle is mostly about the challenges in developing countries and how to still maintain sustainability, and does the high-rise building or a tall building make sense in this world, and particularly in the developing world. With that,
what we're going to do is just give you an overview, and we're going to go fairly quickly because I know we're out of time. But some of those challenges relate to poor infrastructure, constructability, lack of political will and support, also a social structure often defined by economic structures, and how tall buildings can react to that symbolically, economically, and environmentally. And to illustrate that, we're going to show our India Tower project, which is in Mumbai, but we're also going to draw some comparisons to New York City, where we're from. A lot of people aren't familiar with the fact that 100 years ago, New York and the United States was a developing country itself, and so when going back in history, we found some very interesting comparisons.
You know, this quote is an interesting one. It represents a couple of things. It represents globalization, but it also represents the idea of great opportunities that are coming in our way.
And I would just add that, you know, design is the first signal of intention. And we have to ask ourselves as designers, what is our intention? And, you know, I'm reminded of Al Gore's speech at the acceptance of the Nobel Prize, where he said, you know, he was comparing what was our intention when we decided to go into this fossil fuel business. It was to promote industry. It was to advance society and to advance our culture. He never intended it to cause all the harmful effects of global warming. And at the time, he was comparing it to Alfred Nobel's famous invention, which everyone I'm sure is familiar as dynamite, which he never intended to be used for war, and so on.
Anyway, by the way, this is a dialogue between the two of us. As you can see, it's not a lecture, so hopefully we have a conversation with you later. Of course, the technology has influenced us in this world, and this is somebody's imagination that in year 2004, our home computers would look like this.
I think we're using it right now.
Fortunately, we have come a long way. Having said that, by the way, in India, particularly, as their economic growth has been tremendous in the last decade, the construction methodologies are still rudimentary in many cases and require a far more refinement. It's one of the biggest challenges that we're facing.
Yeah, I mean, when trying to talk about tall buildings and all these wonderful projects we've seen, in India, you have to realize it's a $51 billion a year industry with 32 million workers. But most of those workers are suffering tremendous amounts of fatalities, and illnesses are very high due to poor construction controls. And it's caught the attention of the international lending community, in particular the World Bank, and that oversight has not gone unnoticed by the developers who are trying to push through these mega projects.
And here is, by the way, a photograph of actually a New York Times headquarters building, which we just recently finished in New York. These photographs are recent in New York. They still look like the photographs of the 40s and 50s, believe it or not. But nevertheless, the industry in New York is very different. It's much more refined in terms of the way we build it there.
Now, I mentioned the turn of the century, 1900, New York, but just to look to the future for a second, or even present day, this is the famous bow tie, as we call it, or Times Square area in New York. And I would just say that it represents probably the world's greatest transformation. It's both a center of interconnectivity through the use of transportation, intermodal hubs. It's extremely dense, and it is home to some of the most sustainable projects in the world, all tall buildings. You know, here we see the New York City subway system. It's very interesting. This is a mature network, but the idea here was that infrastructure came before the growth. That, you know, the subway lines were laid out, and they went to open farmland, which is now the Upper West Side. in comparison to Mumbai. And as I pulled these slides together, I realized they almost look identical in terms of their geographic configuration. Because after all, Mumbai and New York are both port cities. They're both heavily rooted in industry and commerce. They're also non-political centers. And they are home to the arts and culture and Bollywood and all kinds of things. But you see here more of a developing network of infrastructure, some of which is coming in after the fact. And here, go ahead.
Yeah, well, actually, in Mumbai, it's interesting. The city has, there is an infrastructure, of course, the rail lines, the local systems. It's all in place, but the density that is permitted, or the FSI that is permitted, is still fairly low for such a large city. As a result, the city has grown to a size which is a bit unbelievable. Next, please.
This is an all too familiar site in Mumbai. You're barely being able to cram all of the people that need to use public transportation into this overcrowded, underutilized system. And as we've heard many times today from many of the speakers and in this morning's plenary session, that we really need to remove traffic and capitalize on more energy per capita by using mass transit. And these are I believe this is one of the major...
Yeah, the Churchgate station and some...
there are a lot of opportunities, and in New York right now, believe it or not, we're going back to a lesson we learned around 1905. The picture on the left is Park Avenue. And Park Avenue is where all of the rail lines come into the Grand Central Station in Manhattan. And it was really intended to be used as an industrial rail system to export the goods that would come from the ports. And what was done was the entire rail network was kept at grade and platformed over, and then new high-rise development was put on top. And we're exploring that opportunity today, and it certainly may be applicable to some of Mumbai's open rail systems. And here...
Keep going.
Here we go.
Well, actually, this is a bridge. I think this is just an example of, this is the bridge which we're currently designing in Dubai. The point is the infrastructure does make a big difference, and hopefully in Mumbai it will come there as well.
These are some early maps, again, illustrating, turn of the century New York. And if you sort of look at lower Manhattan, you get a sense of the sort of randomness of it until the normative grid that was put in place started much later. But it speaks to smart growth. And to throw some statistics, we've been studying India. India is growing at 1.3%, and energy is also growing, but it's growing at 4.3%. And the cost of that energy is 2.8% more intensive than the energy that we can provide in some other established countries in terms of its harmful effects. So it's 3 times more energy per person. They're growing, but they're also doing it with much more harmful effects, mostly from coal and diesel burning fuels.
Well, that brings to the India and Mumbai in general. Of course, the statistics has been already said, but Mumbai is on the westerly coast of India, has its unique climatic conditions, and of course density is tremendous. This is on one specific day. This actually is not too far from the site we're working on. Population density is a big issue, so therefore the case for a high-rise buildings actually and a greater FSI is certainly to be made in this part of the world. And of course, there is the other side, which is this is the gray. By the way, one of the sort of these largest slums in Mumbai, with such incredible land values, it still exists, and it's supposed to change in the near future. But we'll see what happens.
A third of the Indian population live in urban areas, and 55% of Mumbai residents live in those slums. So certainly tall building is a plausible and viable solution. And what we see in these photos are very similar conditions in New York City. These are the famous New York tenements, which suffer from the same poor indoor environmental quality, poor infrastructure, bad roads, threat of fire that we saw at that time. And to counteract that, the city did choose to build upward. Building tall continues to be about making a statement, but The symbolic implications of India reaching skyward to a better future fall to those with the means and political clout to effect such a change. Much in the way we had Carnegie, Rockefeller, today we have Tata perhaps, and other patrons in the private sector who have to assume the mantle of responsibility for these developing countries, especially in India where government tends to fall down a little bit in that regard. You know, as an example, you know, our work at 4 Times Square, which is a 1.5 million square foot high rise, which we've documented before. I think the story here, though, is if you remember, Times Square was needed transformation. It was a bit of an urban blight. And what the project team came together, we realized that it wasn't enough to just build as we had built before. It wasn't good enough. And you know, we needed to revitalize Times Square, in the process attain a higher level of development that could demonstrate potential and lead the way to a sustained change in the future. And what we're seeing with India Tower is the same impetus, the same desire to achieve a greater thing and not just repeat the same mistakes of the past.
You know, that brings us to another building. This is the New York Times headquarters building, which is just recently finished. This is also in the similar area, by the way, across the Port Authority, in a blighted area, of course, but it's going to change quite dramatically. The building is extremely sustainable on multiple levels. But again, I do want to quickly reach to India Tower. This is a project which we're doing in Dubai, and another project in the Middle East where the external wall was developed specifically to deal with the energy issues. With that, the climatic conditions of Mumbai.
I mean, the biggest single most impactful element of the Mumbai climate is the monsoon season, which is from June basically to September. And you get a tremendous amount of rainfall during that period, over 1,900 millimeters. That's really the primary driver for the whole design. Mumbai has this tremendous rain, and here you see this is sort of as it's coming, and recently we've seen scenes like this.
I think the point is it adds a lot of issues to deal with when the buildings are designed, not only in terms of humidity, but maintenance issues and so on and so forth. That brings us to the India Tower. I think the idea about Mumbai is that the city has inherent informality, and there is a social stacking that occurs in India, which actually comes out of economic stacking, and therefore idea was that is it possible to consider a tower which then emphasizes the density issue, and is it possible to express that in some stacked manner. And of course Mumbai is a city which is not too dissimilar from New York. Tremendous economic power, the stock exchanges, the theater, and on and on and on. And of course the Gateway India, by the way, even the colonial period, the King George V arrived at this place to then open a New Delhi, the new imperial capital then.
And the point of this is that, and we've heard this before today, iconic architecture possesses authority only when people recognize themselves within its formalized symbolism. And we do our best to translate that as architects.
This is that Queen's necklace, as it is referred to in Mumbai. The site is on this necklace. The red dot shows the location. The views, of course, is right on the ocean. It's the Arabian Sea. As views in all its aspects. And the site, unfortunately, in spite of all of this, is a very small site. It's a very tight site. Again, I will not dwell too much on it. But the idea was then to create a tower with essentially a party of creating crystal-like pieces that then ultimately stack into a tower-like solution. The site plan, and then Peter will talk about it. A section through this building, by the way, it's a complex program from parking to a 5-star hotel, And the lobby space, in this case, the lobby is that cube that you see is up above, and this is the Park Hyatt signature. You go up to come down. Whether that is really sustainable in terms of energy use is another story, but that's their signature. And then, of course, there are residential apartments on top. The building is about 301 meter.
And I realize people are saying to themselves, wow, a hotel, how sustainable can that be? But if you realize that India's middle class is growing at leaps and bounds, and it's really empowered them to be much more mobile, and they've estimated that about $10 billion needs to be spent on 90,000 five-star hotel rooms in India.
Quickly running through the floors, and then the ground floor, study of the retail at the lower level to the typical floors. It's really a stacked floor. Studies of the form, by the way, earlier speakers talked about form being informed by many issues, not just cultural, but also energy issues. So we were going through the similar studies, and then finally came to this conclusion for multiple reasons. Besides the cultural influences, we also wanted to deal with issues of water conservation, energy conservation, which again, Peter will talk about it. And with
well,
that.
you know, I mean, like we've seen with many of the projects, we came to the realization that, and India knows this, that it has outpaced its supply of energy with demand, but there is no water. And so similar strategies for energy conservation in terms of the thermal environment, reducing demand from solar heat gains. But in this climate, dealing with humidity, as well as, I'm just going to scroll through these because I'm getting the sign, you know, as well as how we can recapture some of that rainwater and so on. You know, here, for example, this slide is a depiction of some of our water strategies, and we actually calculated, if I can get to my numbers here, that we are able, with the offsetting of the various components programmatically to create additional roof areas, we actually have the potential to reclaim 7.8 million liters of water. This is only from June to September, and that some of that will be used for irrigation, fire protection systems, and of course in India it's required by the law that you have a full on-site sewage treatment, so all the water is then treated and recycled through the building. Okay, natural ventilation is an issue, of course, with high-rise. We've all heard about the wind pressures and the impact. These are some studies.
Yeah, I think just to conclude, by the way, these are some of the studies that we've done, and brings you to the scheme that we're currently pursuing. Once again, I think the case to be made for Mumbai and potentially for India for higher FSI, greater density, taller sustainable buildings, we are hopeful that I think this will allow us to connect the dots and therefore ultimately improve the infrastructure as well. Well, thank you.
Yes, our paper's in the book.
Thank you very much.